What we're looking at here is a graph of the charging of these two batteries by this solar cell. Alright, let's take a closer look at the graph here. And what we're looking at is a duration of 2 hours of charging. At the initial time, we have a current of 0.08 amps, or approximately 80 milliamps. And as the charging progresses, the current gets lower and lower. The reason for this is that a solar panel is struck by light, and the angle between the solar panel and the incoming light will change, because as the sun passes overhead, the angle changes. Therefore, the current gets less and less. At this point right here, what I did was rotated the solar panel so that it was more directly focused toward the sun. And then about a half hour later, I did the same thing again. So if we rotated it many times, then this current would stay high. Alright, let's take a look at the statistics for the graph that we see right here. And one thing that we're interested in is the mean, which is the average value of the current. And they tell us that the average value is 0.0788 amps, or 78.8 milliamps. So if we were to take the current, multiply it times the time, then we would get the charge. Another way that we could actually do this would be to find the area below the graph, area bound by the graph. So we're talking about the area below here like this. Now, there is a process in calculus called integration that can actually do that mathematically. And nowadays, fortunately, we have the use of computers. If I restart the recording at the beginning of the timeline, does it erase everything that went on there? Now, on the computer we can actually do this, and this fills it in and tells us the area underneath the graph. So by calculation, we have 157.2 milliamp hours of charge that has been delivered to the batteries. Now, you can't see it, but the battery does say right on it how much charge it can hold, a maximum of 800 milliamp hours. That's the charge capacity of these batteries. Right. Now, once the batteries are charged, we can use the charge to run things like light bulbs or motors, etc. Alright, this is the solar power solar cell, and it's charged. We charged these two batteries for 2 hours. Got roughly 160 milliamp hours into it in those 2 hours. And now we're discharging it through this motor, collecting current data. And let's see what we got going here. If we can zoom. Current right now is running at 620 milliamps. Here is a graph that represents the discharge through the motor. Again, we let it run for a couple of hours and recorded the current as a function of time. Let's see if we can interpret what's going on this graph. At the beginning, the current is running at about, well, here's what it says, 6208. That's 620 milliamps. Almost 100 times or 10 times greater than the current that was used to charge the batteries. So we expect really that the batteries are going to discharge much quicker than it was to charge. Now, what's happening here is that the motor starts out running fairly fast, and then after about 15 minutes, the motor stops actually spinning. So all of this charge right underneath this graph was used to make the motor run. After that, the motor was sitting idle, but current is still flowing through it, and charge is still coming out of the batteries, even though the current is not large enough to actually make the motor run. Again, the total area below this graph is going to represent the charge that is being delivered from the batteries. Again, we can look at an integral of the graph, and the computer actually tells us what that integral represents. So we have here 148.5 milliamp hours. So as the batteries are discharged, this tells us how much charge we actually got out of it. Now, looking here at the end, we didn't actually get to zero. Therefore, some of the charge is still in the battery. Remember that the charging data told us that we had a total charge of 157 milliamp hours put into the battery. And since at the end here we didn't actually totally discharge it, there's still a little bit of charge left in the battery.